I'm sure more of you will be joining as time passes. We wanted to be on schedule, so we are starting the program at 3 as informed. It's a very important event today, a conjunction of two of the biggest planets of the solar system, Saturn and Jupiter. Now, what conjunction is and those things, Dr. Duari is the best person to talk about, and I will not be encroaching into his territory. I will just welcome Dr. Duari for giving his valuable time to us and talking to people. This lecture is going to a lot of people, and this is also, it will go on a YouTube channel, so people can also watch it later, maybe any time, and they can download it and keep it for their reference. And it's very important that we take an interest and study such celestial events for one or two important reasons. One is that it puts us in perspective to the cosmos, where we stand, where the solar system stands, where the Milky Way stands, where the whole universe, in the universe, what is our place. We are put in perspective. This is one thing. Another thing is, for the past several days since this was announced, I have been getting some queries like, how will it affect me? Will coronavirus be wiped out, or will it be? Even today, I heard that because of this, that there is a mutant strain of the virus that's coming up in UK now, and how will it affect India and things like that. Now, this is because of the aggressive, campaign of astrologers, perhaps, who keep telling people that whenever something happens like this, whenever there is an eclipse, even on a daily basis, when there is a full moon, when there is a new moon, this happens, you will have a bad day today, you will have a good year next year and all that. So this myth needs to be dispelled very actively by science communicators. And this is, I think, the second and most important reason for studying and understanding what these celestial events mean. And what better person than Dr. David Duari to talk about this? He, the person who was running the Birla Planetarium in Kolkata, and he is also a very popular speaker. He has given more than 1,500 to 2,000 lectures on astronomy related topics. He is an astronomer, certainly, no doubt, but he is more importantly a communicator of science. That is the most important thing. Not all astronomers, not all scientists communicate. It's important for scientists and astronomers to communicate so that people go with a strong message about what is science and what is astronomy, what is potential. And so today we will have a really wonderful lecture by Dr. Duari. And before that, I request Mr. Dinesh Malle to introduce Dr. Duari briefly to all of you who are watching. Mr. Malle.
Thank you, sir. Thank you very much, sir. We are, as Sri said, we are very fortunate that we have with us today Professor Devi Prasad Duari Sahab. Professor Duari Sahab is PhD from Ayuka, and he has done his PhD under the world famous Professor Jayant V. Narlikar Sahab. He is presently Director Research and Academic, MP Birla Institute of Fundamental Research, Kolkata, and he is a faculty to University of Manchester Institute of Science and Technology, UK. He has been awarded with Best Thesis Award of the Astronomical Society of India in 1993-94, and he is a recipient of Rabindra Puskar, Government of West Bengal in 2019. He is also honored with DSc degree from SOA University, Bhubaneswar, Odisha, and he is fellow of the Royal Astronomical Society and member of International Astronomical Union. He is fellow and member of several other institutions also. As ISR said, he has delivered near about 1,450 lectures and 350 live television interviews. He has published 20 international publications to his credit, and he has also written one book, Mahakasher Shahadpat, a cosmic premiere. So he is also honorary visiting faculty to many other universities also. He is the spokesperson to University Grant Commission also. So without wasting much time, I would request Professor Duari Saab to continue with his lecture. Professor Duari Saab.
Thank you very much, National Science Center, Delhi, and especially the officers who have taken an interest and actively supported this program and made it possible. It's really an honor and privilege for me to speak on the portal of one of the topmost centers for science dissemination and activities. NCSM is very close to my heart for the last 10-15 years, but this invitation from NCST, I am thankful to all of you, sir. Thank you very much. Today is special. I think most of the people throughout the world, they have realized that today is special. Actually, I should say not today, rather tonight is special. First of all, you all know that this is going to be the longest night of this year, which is called a winter solstice day. So the night time will be of a long duration. But it is not only that, it is another factor which has made this particular day or night, as you can say, very important. And that is known as conjunction, the great conjunction. The great conjunction of Jupiter and Saturn. Now, these are the two planets which are actually quite prominent in our solar system because of their size and because so many mysteries are still not understood about them. Scientists, they always give importance to issues, objects, which are not fully understood. But what today we will be observing or will be experiencing is just not scientific, deep understanding or mathematical calculation. It's also a visual pleasure in addition to what my predecessor just said, the conception, the understanding, the consciousness about our presence, about our position in the whole scheme of the grand universe. I would definitely like to talk about this issue using a presentation. So if you will allow me, please, all the whoever is watching, please give me some 30 seconds so that I can show you my presentation. Yeah, just a moment. I will just. Can you see it?
No, sir.
Okay, just a moment, just one. I think something is creating there. I checked it just like that, but still, just a moment.
Okay.
Give me, yeah. Can you see it now?
Yes, sir, it's visible.
Yeah.
Good, fantastic. Okay. You all know why we are here today. Most of us sitting in front of a laptop or mobile, just to know a little bit or discuss a little bit about this fantastic event, the great conjunction of Jupiter and Saturn. This picture is not a true picture, but for our earthly people, it will look as if two solar system friends, are holding each other in their arms and presenting themselves for our viewing pleasure. I don't have to tell, I think, much about what is the event, because internet, social media, print media, electronic media, they are abuzz for the last almost 15 days with this event. That in the beginning of the night today, or rather in the evening times, people can observe a celestial wonder where Saturn and Jupiter will appear to be side by side in the sky with a distance of just 0.1 degree in angular sense. And for a long period of time, nobody has seen this. So it is important. So first of all, you all know that this can only happen when looking from the Earth, the two giant planets of our solar system, Jupiter, the biggest one, and Saturn, they appear to be on the same line of sight. I'm using the word appear to be because in addition to all this information, there is a tremendous amount of fake news circulating in the internet about what will happen if Saturn collides with Jupiter. But you can see from yourself, it is not so. By the way, what is the meaning of conjunction? That's a celestial term. But let us come back to our Earth and let us think that you are in a place and in a very far distance, you are seeing one person. Then suddenly you see another person just near him. But you know that these two persons are quite far apart in actual sense. But since your line of sight is crossing both the first person and the nearby person, it will appear to your mind, your eyesight, that they are very close to each other. And in an earthly sense, that is a conjunction. So basically, when two objects in our solar system, one comes very close to the another, we call them that there is a conjunction between those two systems. In that sense, there are certain aspects. We know that Earth is the third planet of the solar system. So Sun, Mercury, Venus, then Earth. So Mercury and Venus are so-called inferior planets. And all the other planets apart from Earth, outward the solar system, starting from Mars, Jupiter, Saturn, they are superior planets. And only when using which object is covering up or coming near one, we call it an inferior conjunction and a superior conjunction. So now you know this conjunction of Jupiter and Saturn is a part of the superior conjunction. But additionally, it is also called the great conjunction. Why great? Because both Jupiter and Saturn are gas giants. And just because of their size, they are called also the great conjunctions. So opposition and conjunction. Opposition happens when you see the sun, the earth, and another object in the sky in that particular alignment, right? And conjunction generally happens when there is a sun, earth, and some other objects in the sky. Now, technically, a conjunction means when two celestial objects are at the same right ascension. By the way, right ascension is an angular measure to find out a position on the sky. Not just one, but there is another one called declination. But basically, right ascension is the amount of the angle which is measured from vernal equinox eastward to our point on the celestial equator, that is Earth's equator expanded and imaginary circle, a celestial equator is thought about, and that plane is the celestial equator. And that point is basically from the object in the sky, if you drop a perpendicular, it will be that point. So two objects in the more or less same right ascension are said to be in conjunction. Now, this is a little fun. Same game, different name. Two objects can come close by, but we generally see these terms called occultation, transit, conjunction, and eclipse. What are they? Consider two objects in the sky, a red one, which is close to you, and a blue one, which is far than you. Now, if the further object, the blue object, is quite far away and small in size, so that while this celestial continuous motion is going on, a part of it or the completely, it gets obscured by the nearer red object, we call it an occultation occurring. Now, if the foreground object, in this case the red one, is quite small compared to the back, and if it crosses that big object, for us, we call it a transit. And then two objects coming close to each other, conjunction. And one of the extreme example is an eclipse. Yes, when moon either completely or on an annular sense covers up the sun as seen from the earth, we call it eclipse. But basically, they are of the same nature. So conjunction is not a very, very important thing on its own only. The whole issue of occultation, transit, conjunction, eclipse, they all fall in the same category. And today, this is what you are going to see if you have a big telescope, or if the National Science Center has got a more or less a big telescope. Jupiter and Saturn close to each other. The angular distance between them is only 0.1 degree, 1/10 of a degree, 6.2 arc minutes. And with a bigger telescope, you can not only see Jupiter and Saturn, but at least 3 to 4 moons of Jupiter and some of the moons called Rhea or Titan or others of Saturn. Beautiful. In a single field of view, using a telescope or a binocular, you can see two objects in the same time. And this is the progression of event. You know, at the beginning of a madness, I will say. And here you can see from, 15th of December onwards, as you can see here, slowly Jupiter and Saturn as if creeping towards each other. Here, each of this line is 1 degree and 1 degree apart, this box. And you see 16th, 17th, 18th, 19th, 20th, and the grand finale, 21st December, tonight. All at around 6 p.m., how their position was. So that tells you as if they're approaching each other. But we know they're not approaching each other. They're just going on in their own nice way in their orbit around the sun, the orbits being very far apart. Now, why this has become important? Because, my friend, if you do some calculation or go through an almanac and see that this 6.1 arc second separation or 0.1 degree separation happened last 1623, 16th of July. So this is the closest separation that occurred since 1623. But if you are really interested into knowing how close they can become, then 5th March 1226, 2.1 arc second. 1226, we really do not know what is the situation anywhere on the earth. A little bit of history we know, but not the details, at least in science and technology. I don't know whether there was any technology in that sense in today's parlance. 1623 was good because just 1609, Galileo Galilei has invented the telescope. And there was a madness to observe the sky, the different objects, using this newfound instrument, which was like a magic. But again, something happened. 1623, 16 July, the conjunction was not very clearly seen by at least people at higher latitudes because it was close to the sun. So the sun's rays, the sun's illumination drowned out the conjunction thing. And that is the reason suddenly today evening, 21st December 2020, it has taken this dimension of importance that it has to be seen. It will happen again. I will explain that it happens quite regularly. As you can see, 2020, 2040. So maybe 20 years. But such a closeness is not to be seen. For example, in 2040, the next time it will happen 1.2 degrees apart, right? So which is 0.1, meaning 12 times the distance that we will be seeing today. And it will be very comparable to of today on 15th of March, 2080. I think many people on earth, definitely me, will not be around in 2080 to see this. Before I go, let me talk about that how this happens. Why not I see two solar system planets in any direction on the sky? That you have to talk about the formation of the solar system. According to the scientists, 460 crore years back, a huge cloud of gas and dust was floating in space. In terms of number of particles, this cloud was made up of 91% hydrogen, 8% helium, and 1% rest other elements. The average temperature of this gas cloud was minus 240 degrees centigrade. So at this cold temperature, the force of self-gravity was the only force, so the cloud became contracting. At the center, the pressure density rose, the temperature rose, and ultimately reached a level of 1.5 crore degrees centigrade, which is enough to fuse 4 hydrogen nuclei to produce a helium nucleus. And the sun was born. And as it was spinning originally, because of the conservation of angular momentum, as it shrank because of gravity, it condensed into a disk. At the central part of the disk, when the sun was born, in the outer periphery where the temperature was less, gas and dust condensed, coagulated, and gave birth to the other objects in the solar system. So you may imagine, this is a cartoon. You may imagine that 460 crore years back, this was probably the scenario of our solar system. Sun at the center and most of the material in the disk region. And in this disk, because of tremendous amount of collisions, condensations, accretion, material start forming and ultimately gave birth to our planetary objects. Initially, those planetary objects are very hot, molten almost. But over millions of years, they dissipated away the heat, and at least the first 4, Mercury, Venus, Earth, Mars, became rocky or terrestrial. Whereas the other 4, Jupiter, Saturn, Uranus, and Neptune, they're mostly made up of gas. Now you see, even in this picture, in the lower panel, because they formed out of a disk mostly, there is an alignment along the disk, and that is important. So, Earth is going around the sun. So if I now consider the plane of revolution of Earth around the sun, That plane is called the ecliptic, loci of eclipses. Rather, that plane is called the ecliptic plane. We all also know that Earth is going round the sun around an axis, and it goes round itself once in 24 hours around another axis. And these two axes are not parallel. They're inclined at an angle of 23.5 degrees. So, if I now consider in my mind the celestial equatorial plane and the ecliptic plane, because of this tilt, which is accidental, by the way, which a lot of scientists believe happened when Moon was born. That is another story. I'm not going into that today. There is a tilt between these two planes, ecliptic plane and celestial equatorial plane. And that is the beginning story of our home in the cosmos, where we stay, the solar system. A little bit of things about the solar system. On the upper panel, you can see Sun compared to, in size, the other planets. Almost Earth becomes a dot in that. Believe me, my friend. And comparison in size of other planets with each other, Jupiter and Saturn, you can see for yourself why it is called a great conjunction. Just the size will tell you, right? And this goes on in a continuous motion around the sun, our guiding star. But though we expect that everything has been formed in a disk, but don't consider the disk of gas and dust which gave birth to the planets as a very thin sort of a, like a paper thin, wafer thin object. It has its width. As a result, and because of the initial perturbations of these planets, because of innumerable collisions, there is a tilt, an inclination towards this disk. If I now consider Earth and the sun, the plane, to be very sacred, because we all observe from Earth, and we called it an ecliptic, there is an inclination to the ecliptic of every planet as they're going round. Mercury is a little bigger, 7.01 degree, Venus 3.39, Earth, obviously, since it is on the plane on which the reference is, it will be 0 degree, Mars 1.585, Jupiter, Saturn, Uranus, and Neptune. You can see for yourself. Except Pluto, which was in 2006 kicked out of the planethood membership. Because one of the factors was its inclination to the ecliptic was around 17 degrees. So now you expect, as you can see from this photograph image, that looking from Earth in particular direction on particular time, you can see two objects coming close to each other. And this is not only for Jupiter only or Saturn. This planetary alignment, because they all are a part of the disk, happens quite often. This is a wonderful picture taken in La Paranal in Chile, the home of very large telescope, right? Here is sub-millimeter telescopes, and you see Mars, Jupiter, Mercury, Venus, almost following a pattern. The pattern is the plane of the ecliptic. Now, if you now take objects in the solar system, they have different periods of revolution. Earth, you all know, 365.25 days. Jupiter, 11.86 years. Pluto, 248 years. Saturn, 29.4 years. So, time to time, because of the different speeds of the planets, according to their distance, according to their orbit size, two objects can come close to each other, conjunctions, right? If you're in some other planet, you can see Earth and some other planets conjunction, definitely. But there is a calculation. It's a small calculation. So if you take this diagonal, right, with Venus and Sun, every 1.599 years. With Saturn and Jupiter, you can see 19.859 years. And today they are our main actors of the drama. So we should expect every 20 years this should happen. Why 20 years? because there are a lot of students in the audience, I wanted to say, intervals between two conjunction is calculated roughly by a very simple elementary formula. 1 by P1, where P1 is an object, is a planet which has a shorter period, minus 1 by P2, longer period. So if you now just use your basic mobile phone calculator, putting P1 as 11.8 years and P2 as 29.4 years, you can show roughly they should come to each other conjunct. Conjunctions will occur every 19.8, 19.9 years. So 2020, 2000 it happened, 1980 it happened, 2040 it is going to happen, 60 it is going to happen, but it will not be as close as it is today. And this was known for a long time. On the left hand, my left hand side, that will be your right hand side probably, even Kepler, Johannes Kepler, had this diagram which he called Tigon, that 3 conjunctions of these 2 great planets occur in a pattern, right? And as if it is this isosceles triangle, 60 degrees apart, each corner, and they occur this way. And in a modern sense, if you do the calculation, you can see from the view graph itself, from the slide itself, that they are bunched together. If you take a 360-degree turn, by the way, why 360-degree turn? Because Earth is going around the sun. So it appears to us as if these objects are going around the Earth in some sense, even sun. Because you all know, sky is a 2-dimensional area. So we see sun projected on a particular part of the sky any day. And as we are moving around the sun, it appears to us as if sun is making a round trip around me. And this imaginary path of the sun around the earth, as it appears, is the ecliptic, which I earlier told you, right? So that gives us a sense in the sky that everything is going around us as if. Remember, it is not so. First of all, we are turning from west to east. That's why east to west objects go. And then in these sort of aspects also. So today's discussion, the separation. In a nice picture here, you see September 21, October 21, November 21, December 5, December 15, December 21. As if 2 objects in the sky by some invisible force approaching towards each other. But believe me, my friend, there is no invisible force in that sense which is drawing them apart. The invisible force that is there, sun and these planets, which is making them go around the sun, or even between each other, the gravitational interactions between them, but just their simple positions on the sky is giving us this beautiful thing. And how the angle has changed, the angle of separation has changed from, say, December 6 to January 5. So that tells you one thing. Don't wait for this event. Okay, tomorrow I will see it. 5 days later, I can also see it. No, the separation is going to change very fast. By the way, I am talking about 0.1 degree, 1 degree. What is that? You don't have to get sophisticated instrument. Just see this view graph. Just by extending your hand in front of your eyes, extending your hand, you see how you can measure 10 degrees, 25 degrees, 1 degree, 3 degree, 4 degree separation on the sky. This is a very useful tool to understand the objects and their positions on the sky. And the graph below, I think it is the mostly widely circulated graph about this conjunction in the world. It was created by a British amateur astronomer, but accepted by everybody. Most of the places, they don't have the courtesy to mention who has created this. And it shows how this separation has decreased. And the upper panel, starting from December 17, what is the red circle? The red circle is the apparent size of moon as we see on the sky, which is angular diameter, you all know, 0.5 degrees, half a degree. So you see, taking the extent of the moon, they're approaching much closer and ultimately ending up at December 21, which is 1/5 of the diameter of the moon as we see from the earth. And as I mentioned, conjunction again, just to hammer it in your mind, two objects coming close by, coming closer, closer, and today ending at the last panel, one on top of the other almost. Lot of doomsday sayers, lot of people who does lot of calculation but never uses it for the benefit of the science. Sorry to say. They are saying, even I got so many messages. Then what is going to happen, sir, if Saturn is going to crash onto Jupiter because they're coming so closer? I said, don't be fooled by these people. Because tonight, when Saturn and Jupiter will be observed in the sky, almost one on top of the other, as if the difference between them in their position, the distance between them will be 73 crore kilometers, 730 million kilometers. Just imagine the distance. Earth is only how much? You all know, 15 crore kilometers away from Sun. And this is 730 million kilometers. So forget about all those almost nonsensical claims that one is going to fall on other, does something which can cause a lot of other things. Just enjoy this small angle of separation. Naked eye, you can just able to identify them. But if you have a binocular or a telescope, very good. National Science Center, Delhi, and so many other centers throughout the country. That is the triumph of science popularization, bringing science to the people, bringing science to the young minds, to enthuse them, to understand, perceive, conceive concepts about us and our surroundings. Surroundings does not mean only the river, the lakes, the mountains, or the neighborhood houses. We also mean surroundings, the great surroundings, the whole cosmos. This picture was taken by an amateur astronomer just 3 days back with a telescope, I think 8-inch telescope. And you can see, absolutely beautiful, right? Io, Europa, Callisto, so means this is Jupiter. This is Jupiter. And Titan, one of the biggest moon of Saturn, close by. And this picture was taken by a very famous fellow, Dorji Angchuk. He is one of the officers at the Indian Institute of Astrophysics in Bangalore, but he has taken this in Leh, with the cold climate, but very clear sky. And you can see for yourself. So be the first in observing this event since telescope was invented. Today, if you can see this, give yourself a certificate, because this is such a fantastic thing that has happened, right? Notable times, you can see station, sunset time, Jupiter Saturn setting time. New Delhi, 5:28, sorry, it is, I think, automatically going. 5:28, sun will set, 7:45, Jupiter Saturn. Kolkata, 4:57, 7:12. Mumbai, 6:08:20. Chennai, 5:47, 7:58. Bangalore, 5:58, 8:11. Basically, that means not much time for you to see. Just 1.5 hours roughly, because just after the sun goes down, you have to give some time for the sunlight to die down. Otherwise, you cannot see them. So roughly around 1.5 hours at the most. Enjoy that. And as I told you, timetable-wise, you can see these are the famous timetables, right? 12/26, December 21, and further days. So today is memorable. Be a witness to this celestial wonder. But at the beginning, I told you, it's the longest night as well. And that happens because of these two tilts of the revolution axis and the spin axis. That is the reason one part of the year you get more amount of sunlight in the northern hemisphere, another part less sunlight. More sunlight, more direct sunlight, summer, less direct sunlight, winter. So change of seasons occurs also for that, but that's a different story. But because of this tilt, you can show 21st of December, Northern hemisphere will experience less amount of daytime. And that is called the day of winter solstice in Northern hemisphere and summer solstice in Southern hemisphere. Right? You can see from this slide how sunlights are falling almost directly onto the Southern hemisphere more. And you can see the Northern hemisphere within that sort of shadowy range more than the South. And that also means that on December 21, the height of the sun on the sky at the midday will be the lowest towards the southern direction compared to the other days, right? And this variation has given us 4 important dates: 28th of March or 21st vernal equinox or spring equinox, 21st of June summer solstice, 22nd of September autumnal equinox, and 21st or 22nd of December winter solstice. These are for the northern hemisphere because we are all northern hemisphere people. Night, the sun will appear at the point of vernal equinox at 3:33 p.m. Indian Standard Time. The duration of night in Delhi will be 13 hours 41 minutes, Kolkata 13 hours 15 minutes, Mumbai 13 hours 1 minute, Bengaluru 12 hours 39 minutes. But if you go to the southern hemisphere, it will be the sunlight duration will be much more. For example, Melbourne 14 hours 47 minutes. And think of this city called Inver Kargil, right? It's the southernmost city on our earth, which is locally people stay there, inhabited. 15 hours 48 minutes will be the daytime today. If I talk about a little bit of history, originally, conjunction events were linked with bad or good omens. Something will happen. Almost thousands of years back. Some problems on earth, some pandemic, some destruction, some earthquake. Everybody is afraid. Astrologically, during those times, they were considered significant events. My friend, science changes almost every day, every month, every year, every decade. Astrology hasn't changed much. So astrologically, they're still considered significant events. Right? I don't know. How should we believe it? 21st century, the modern man or woman. India, I think I can be very proud of this as an Indian. Because it's a long history of astronomical recordings and text of things happening on the sky. Do you know, when can you go back up to till what time? 12,000 BC. Can you believe it? They have discovered these sort of sticks in Andamans where the lunar phases are nicely etched upon, given how the phase of the moon changes. But prehistoric times, the important era was 3rd century to 1st century BC. Tremendous growth in our understanding in Hindu civilization, Jain civilization culture, but later on, only influences from Babylonian, Greek, and Roman civilization entered into the Indian astronomical scenario. But the golden age is the Siddhantic era. Aryabhatta, starting from 5th century AD. Aryabhatta, Barahamihir, Brahmagupta, Bhaskara, so many names, right? They all wrote Siddhantas, conclusions, principles. For example, in Brahmagupta's Supta Siddhanta, there are mentions about not only conjunctions, eclipses, but even a concept of the timings of these conjunctions. Later period, just after that, many important astronomical observations happened. But sadly, not many records available to general people. Really are the common people. What happened to India? India is a great civilization, great culture. A lot of things did happen, but not that mentionable. And there was an additional influence of Western concepts. Because after Renaissance, during Renaissance period in Europe, there was an explosion of concepts and ideas, freedom of thought. People came out with very, very different concepts, proved them, and that became a part of our scientific understanding. So that slowly made their ingress to Indian context. But I'm not sad, but the truth is, for a long time, just maybe 100, 200 years back, till that, it was taken to be seriously on astrological sense, conjunctions. And it is still being taken seriously by not that many people maybe, but some number of people. Now the question, some places you see great conjunction happening up to 397 years. Some places 794 years. It all depends what is your position on Earth. March 5, 1226, it was just before dawn. Sunrise was 5:47 a.m. This is if I take Calcutta, by the way, where Jupiter-Saturn rise was 3:15 a.m. So much prior to the rising of the sun, people could see very close to each other, these two objects. But no telescope that time. 1623 telescope happened, July 16, but see the timings. Sunset 6:25 p.m., Jupiter-Saturn 7:12 p.m. So almost within half an hour apart. And northern latitude people could hardly see it because it was almost buried in the sunlight. Southern, near the equator, I was actually doing some calculation and checking. Maybe some of the people, if the sky condition was such, may have seen this. Say, near the equator, Indonesia, Africa, that part, even maybe Indian subcontinent, southern part, but nobody knows. So July 16, 1623 was the last, it came so close. It is the closest today since 1623. But seen by most of the people around will be 1226. That's why this dilemma, dichotomy in this internet, after 800 years, some say after 400 years. And there are also some things, Christmas star. Why? What is the origin? Because in 7 BC, there was a triple conjunctions. This conjunction happening thrice in a year. It was calculated by Kepler as well as there was a supernova. So that gave the rise to the story. These were the three guiding stars to the Magi, to the learned people who ultimately went to Bethlehem during the birth of Jesus Christ. The story goes. But there is some cosmic calculations which are done to link it up with what is called a Christmas star. But I don't have much faith on that. It is an internationally important event, believe me. Google Doodle today morning, you have all opened Google, hopefully. And you see this fantastic Google Doodle that they have shown us, right? So enjoy. December 21, this alignment of these two planets, you should enjoy in a fantastic way and remember it almost for your lifetime. Thank you very much.
Welcome, sir.
Thank you.
Thank you, Dr. Prashad sir, for such a wonderful talk. You explained everything in a very simple manner. I was worried that it was a difficult mathematics, but you made it very simple. We don't know. So I would request those other participants, they can ask questions if they have any. And meanwhile, I would request if there are some, they can put question on YouTube comment box also, so that we can ask Professor Devi Prashad Duari to answer those.
Yeah, I request the participants, if you have a query or a question, you can ask Dr. Duari.
Those who are on Google Meet, they can directly ask. Switch on your mic and you can ask the questions.
Anyone, please? And the meantime, basically, we are streaming the same video in a YouTube of National Science Center channel, NSCD TV. So I'm just checking whether some questions are there.
Meanwhile, sir, I would like to ask one question. No doubt, actually, they are so far, 730 million kilometers apart. but still they are coming very close to each other in orbit point of view, also from the distance point of view, because they may be separated more than it. So, will there be any minute gravitational changes or impact on each other?
See, gravitational force is 1 by r square force.
Yeah, I agree.
730 million kilometer r square, the effect will be totally diluted. And though there will be minor perturbations in the orbit, I'm not saying that nothing is going to happen. But
Yeah.
those minor perturbation compared to our Earth and our viewing and the overall effect on solar system is absolutely negligible. That much I can say.
Okay.
Any questions?
Any questions?
No. Okay. On YouTube, we don't have any question. Only people are thanking, providing their regards to the sir for this beautiful lecture on YouTube comment box.
Can you read out few comments?
Yeah, it's thank you, sir. Very informative. Thanks, sir. And one question is there. Ankur Jain is asking in which direction I have to see from Delhi to see the conjunction.
Southwestern direction. Southwestern direction. Around 5:30, it will be around, say, close to 20 degrees above the horizon. Southwesterly direction. And as time will go by, slowly it will go down. And by 7:12, it will set.
Yeah, I think something is there in the chat box. I just check it out. Paras, chat box.
Okay, if there is no more question, I think they can post us and we can send it to Professor
Definitely.
Duari Saab to answer those
Definitely.
questions. Thank you very much for sparing your valuable time, sir. I think you have explained in the simplest way which is possible. And I was also worried that it has a very complicated mathematics involved in it, but it was not. You explained it very nicely. Thank you very much for sparing your valuable time, sir.
Thank
So
you.
we'd
Thank you.
like to have your lectures with us in future also on different whenever such event arises. Thank you very much, sir. Thank you very much.
Thank you. Thank you. Bye. Bye. Take care. Have a good time.
Thank you all. Thank you, sir.
Thank you. I also thank to all the audience which joined us for this lecture on YouTube and Google Meet. And I'm also thankful to my team for organizing such a wonderful event in an interesting way. I think there was a little minute technical snag, but otherwise everything went very well. Thank you, sir. So nice of you. Thank you very much, sir. Thank you.
क्या बताना है इसको?
Mike.
So may I leave?